Hello friends, welcome back to the bench. Yesterday we have been sent on a wild goose chase trying to fix the MSI board, which wouldn't turn on. I mean, it would turn on, but there was no vCore, no SA, no IO, and the memory rail was low. But when I was kind of flipping the board, measuring on the back side, suddenly it turned on, right? And that's why I thought it was maybe the caps. It could be, it could have been. It was the caps, but it was the caps on the CPU. So CPU cut shorts because the caps were damaged. And as I was moving it around, it rearranged enough that the short was relieved. That's why the board turned on and the vCore was present. Bless you. And that's why I couldn't reproduce it later. All right. So finally, I identified that this is our culprit. So it's basically our CPU was busted. That's why it's important to have like 2, 3, maybe even 5 of the same CPU kind or type to test on the boards, because sometimes you just kind of assume that it's that the component you're using for testing is working properly, and it isn't, and then you basically do what I did yesterday, working on that board. Now I do have plenty of caps, but as you can see, wrong size, right? Way too big. So I can't use new ones from over here, but I do have another CPU which has shorted core. All of these caps are good, as we injected the voltage to confirm that none of the caps is getting hot. So these caps are expected to be good. So we're just going to replace the caps over here and see if that relieves the short. I expect it will, because the board did turn on once, right? So I think it's just the rearrangement of those little particles that started shorting out, right? And we have plenty of them here, right? So let's clean it and let's see if we can replace the caps. It actually, for testing purposes of the electrical testing of the board, we can just remove those caps and just leave them absent, because that only will impact the performance of the CPU, because the voltages are not going to be, voltages are going to be not stable enough for the CPU to work properly, to work efficiently. But it will allow us to at least go into the BIOS. I would expect maybe when we boot to the system there would be some issues, maybe, but at least to confirm that the board turns on and it goes into BIOS, that should be enough. So let's get it done. Alrighty, so the caps are removed. Now I assure you it looks a lot easier when you see it on camera. The problem or the challenge of this is that first of all the CPU is designed in a way to dissipate heat, right? So soldering, desoldering, anything over here, especially with lead-free solder, is going to be very challenging. So as you saw, I used both hot air and the soldering iron to get the temperature. The other problem that can often occur is the cup will just weld itself to the pads, and even though the temperature is correct, the temperature is high enough, the cup won't let loose. In which case you can either do what I did with the soldering iron and just a little bit of force, or grind it off. That's the other solution for this. But I did check for shorts. So the majority, when I removed these two caps, at first some of the shorts were gone and some of the shorts were still there. So let's check again. We still have short over here. That's too bad. Even with caps removed. This rail is good. This is shorted. This is shorted. This is shorted. So some rails are good, some are shorted. This is good. This is good. This is perfect. This is okay. Here's okay. Yeah, so we still have a short, and I was hoping that those caps still being there were shorting out. But looks like we have either, oh, there's one more spec here. So either we have another cap shorted or the core shorted out. I wouldn't expect the core to short out from the caps being damaged, but I guess that's possible. Let's check on these. Yeah, this is fine. And this is fine. So the majority of our rails are good. But unfortunately, this one was it. Yeah, this one, oh no, this is 8.4. Hang on, to which one did I check that was shorted? Oh, this one. This one here, or, well, we don't know if this is the cup that is shorted or the core is shorted. Yeah. So these two are low or almost dead short. Yeah. 0.5. I don't know, 0.5, is the 0.5 good? Yeah, 0.5, so that's not a dead short. 0.6, 0.4. It's a little low. For i3, I do not expect that the resistance would be this low, half an ohm. But there is a way we can make sure. If we place the CPU on the board, we can check the resistance on the coils. Before, when we measured on the coils, we had 0 everywhere. Everywhere was short to ground. So let's check now. Yeah, we have 0.5 here, 0.8, 0.7, 0.6. So it looks like it's the core that is shorted. Here we have 1.1. Oh, and it's going down because we have capacitors over here, so it will behave like this. Yeah, all of this. Here we have on the what was it, GT, 3 ohms. That is fine. So GT is okay. Let's see the IO. IO is fine, and SA. Oops. And SA is fine. All right. So we have a short on core. Yeah, this should be around 3, I would say 3.5 ohms on this particular CPU, and definitely not 0.5. So the question is, did the faulty caps cause the core to short out? Or did the core just short out during testing? It is also possible, unfortunately. Let's do one more visual. All right, so here's the diagnosis. It was short everywhere, right? Now it's only short on the core. So SA, IO are good, but not the core. Why would the core be shorted now? Could the faulty cap cause the core short? I don't think so. I wouldn't say so. I think it's more likely that when I was testing the board, right, it did turn on and the CPU became hot, right? They do have thermal shutdown. They shouldn't burn. Even if you put them without the heatsink, they will throttle to not cause the damage to itself. So it's rather unlikely that it would short out because of that, but it is a possibility that when I was testing it, there was no heatsink on the CPU, and when I noticed that it turned on, it was pretty hot, right? So did it overheat and now the core is shorted? It is unfortunately a possibility. I would say rather unlikely, because the CPUs should not burn themselves. They should go through thermal shutdown procedure. But I injected 1 volt to the rail, and I don't see any cap getting hot. It's the whole CPU that's getting hot. But one last test that we can do is just try to turn on the board. I don't think it'll work. I think it'll be the same issue, the no V core, but the memory rail should work now. And we'll see. I'll just turn it on quickly and see if it starts warming up. If it is, then I'll move further. But for now, let's just do the finger test. CPU is cold. which means no vcore because of the short. But let's see if the memory is working now. The memory is still not working. And yeah, SA and IO also not working, but that is explained by vcore being in shutdown. Place it correctly? I think I did, yeah. Just one last try. CPU is cold. I think it was the problem with this board all along was just that CPU. But and I was expecting that the memory rail will go up, because memory rail being low is explained by the short on CPU, because that memory rail also makes it to the CPU. But I think it makes it to, yeah, I don't know, maybe it makes it to the core. Yeah. Well, CPU is a goner. No, there's nothing we can do with it. Nothing more we can do. The cup would, if there was more shorted cups, they would likely show up on the thermal image when we inject voltage to vcore. It's not 100% because, you know, the camera is not, doesn't have the lens to kind of zoom in on these, and this is tiny. This is tiny, so it could be that I missed it, but I would expect to see like a tiny blob, tiny little light somewhere if it was the shorted cup. We could just remove all the cups on that rail, right? If it was a simple procedure. But as you see, removing cups from the CPU is not as easy. So this is more time consuming than actually testing with the thermal image. Well, that's the only 1200 CPU that I have. So that is too bad, because I won't be able to test that board. But I'm pretty sure the only issue with that board was this CPU. That's why it didn't work, and I'm just gonna prep it for the socket replacement. The sockets are on the way and should make it to me maybe next week, maybe the week after that, so we'll know. But I also need to locate a 1200 socket CPU, and too bad, because this is i3 10th generation. I usually get like 5, 6, 7 tops just for testing, because, you know, I don't care, I just need the working CPU. So it's too bad that this one suffered this fate, and I still don't know when that happened, how it happened, and when it happened. But it must have been because the friend that sent me this CPU did use it and it was working, right? So question is, when it was sent, when it was placed in the box, was this fault already on the CPU? If it wasn't, was it during shipping? Did the shipping Yeah, the box said don't no dropping and stuff like that, but have you seen how USPS treats their packages? Or pretty much any carrier, it's not unique to any particular carrier. It's just, those delivery people, they're underpaid, overworked, so yeah, they're not gonna care about your package, and I'm not gonna blame them for that. It's our responsibility to pack it properly. I always say that it should be packed well enough that you can drop it from the second floor, and nothing will happen to it. That's my so I'm not gonna complain about the underpaid and overworked delivery persons. But the way this was packed, I would not expect the CPU to acquire this fault. But if it made it to me untouched, meaning working, I can't think of any reason why it would break on my bench. It's not like it was dropped. It's not like I have enough room over here. Nothing falls down, and I keep them in the package. When I'm not using it, I put it back in the box like this, and even if it falls now, it's not gonna suffer this particular fault. This looks like it was crushed, but surprisingly the smaller cups were crushed, not the bigger cups. I don't know, I'll think about it a little more, but it looks like this is no fixed CPU, which is pretty common. Fixing CPUs is relatively unusual, and success ratio is relatively low, because it's only the cups that we can fix. There's nothing else we can do with it. Well, other than the bent pins or broken pins and stuff like that, but this one obviously doesn't have pins, so it's gonna go to the collection of broken CPUs, and I'll see if I can locate some 1200 CPU that I could use for testing. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.